All right, so how many of you are Monty Python fans? And now for something completely different. We've talked for a long time about kind of introductory stuff, what phylogenetic perspective is, talked about the trees. Generally, what we're going to spend the next big chunk of this class doing is taking a walk through the phylogenetic trees, starting with the bacteria, and we'll do the eukaryotes and the archaea as well. So this is a phylogenetic tree of the bacteria. Now, obviously, this tree would vary depending on what kind of representatives you include. But these are essentially the classic major divisions of bacteria, sometimes called phyla, sometimes called kingdoms. And it certainly is the case that this is an arbitrary selection. There are over 200 of these phyla or kingdoms. If you look at environmental sequences, include one-off organisms and this sort of thing. And some of these groups don't include very many representatives either. So exactly where you draw the line on what's a major class of bacteria, it is arbitrary. But primarily for historical reasons, these are kind of I think there's 13 of them, they're generally considered major categories of creatures. There are 3 early primitive thermophilic branches. So here's Aquifex, Thermatoga, and then the Deinococcus thermus group, and maybe the green non-sulfurs. And then kind of a main radiation. The details of these early branches are very unclear. Some people would draw a fig leaf over this and just show all the main radiations out of it. Whether these deep branches are real or not is a really interesting question. There are also some less major deep branches or less deep branches. The Dinococci and thermus, spirochetes you've all heard of. You probably are familiar with the pathogens, right? But their spirochetes are quite common in the environment as well. The green sulfur bacteria, most people are unfamiliar with those. The so-called sphingobacteria or Cytophaga Bacteroides Phlegobacterium group, these are really, really abundant creatures in the environment, but there aren't very many pathogens or industrially important organisms, so you won't hear much about them. The planktomycetes, these are just too cool, they're beyond belief cool. We'll talk about those later. Chlamydia, hopefully they are unfamiliar to you. The 2 kinds of gram-positive bacteria, the actinobacteria, sometimes called the high GC gram-positive bacteria. These include things like Mycobacterium, the acid-fast bacteria, etc. And the firmicutes, these are the ones you think of most, things like Bacillus, Staphylococcus, lactic acid bacteria, Clostridium, etc. Cyanobacteria, these are not algae, these are bacteria. And then the proteobacteria. In the classical division of bacteria, there are basically the gram-positive and gram-negatives. Most of the organisms you think of as gram-negatives are proteobacteria. Yeah?
So the gram-positive have the firmicutes next to them?
Yes. Let me show you where those are. Oops. So you have a question? Yeah, so these 2 right here. Realistically, this branch is uncertain. And so we have 2 branches that are traditionally considered to be gram-positive bacteria. And most of these organisms will stain gram-positive. When we talk about these organisms, we'll talk about what gram-positive really means, because there are several different meanings to the term gram-positive. Let me give you an example. One meaning is that they lack an outer membrane, right? But the problem is, although these lack an outer membrane, most of these do not. These lack an outer membrane. All the rest of them have an outer membrane. So if the outer membrane is what you consider gram-positive, then these are also gram-positive. If staining gram-positive is all you mean, then most of the archaea are gram-positive as well. That doesn't mean anything, right? Most of these organisms have an outer membrane. It's a misspelling there. Made of mycolic acid rather than lipopolysaccharide. And many of the branches in this group that come down deep actually have a standard issue outer membrane and gram-negative cell envelope. So that whole gram-negative, gram-positive thing is something we'll talk about. Yeah?
Isn't a mitochondria an alpha proteobacteria?
Yes, mitochondria are alpha proteobacteria, and so they're in here somewhere.
That's gram-negative.
Yeah. Cool. So we're gonna walk through each of these branches, and we're gonna start with these two.